On the other hand, if we want to find things in terms of splitting up tangent of alpha plus or minus beta, for tangent of alpha plus beta, we have tangent of alpha plus tangent of beta over 1 minus tangent of alpha tangent of beta, while for tangent of alpha minus beta, we get tangent of alpha minus tangent of beta over 1 plus tangent of alpha tangent of beta. So, if we want to talk about what these each kind of look like, the tangent of a sum is equal to the tangent of the first plus the tangent of the second divided by 1 minus their product, whereas the difference is the difference of tangent of the two angles over 1 plus the product of tangent at each. So, if we want to verify that tangent of x minus pi is equal to tangent of x, that is, if we want to show that the period of tangent is pi, as we've said before, we can use these formulas. We can take that value for tangent of x minus pi and pull it apart in terms of that distance difference formula, where we would get tangent of x minus tangent of pi divided by 1 plus tangent of x tangent of pi. Just apply the formula directly. Doesn't look like we helped at all, but some important things happen now. Vertical lines to that. Because tangent of pi, well, at pi, we're along the x-axis. Along the x-axis, y is equal to 0. So that's 0, and that's 0, which means this term goes away, and that term goes away. And what we'd be left with is tangent of x over 1, or, if you prefer, as most would, just tangent, which confirms that the period of tangent is pi, as we've already seen. But here we got a nice algebraic argument for why that happens. And for the curious, I made some adjustments to these examples here. I essentially used the ones that came with the PowerPoint, but switched around some trig functions in some places and changed some sums to differences in others. I imagine you're going to want more practice with this. I imagine you're going to want more work with this. So if you want to see more examples, check the slides, because there are fundamentally the same problems in there, but it may be illuminating to see them in slightly different ways, so you can see how these values change, you can see how these things get shifted around, and plus, it's always good to get more of the ideas for what's going on here, with some more examples to compare what you're working on to. Anyway, essentially these are all the things we're going to look at for 5.2, is ways we can use the sum and difference formulas to either verify identities or determine information about the values of functions given information about parts of them, or just compute numbers that don't say exactly what they are on the tin. In any case, we're going to finish here by moving into section 5.3, where essentially, for most of what we're going to do is apply these formulas specifically to cases where we are looking at multiples. That is, we're going to look at the double angle formula as well as the half angle formulas, and kind of using those, we're going to get things called the power reducing formulas. That's all 5.3 stuff, which we'll see next.